video. Okay, last class I think we discussed few examples on the combination. This was the last example we discussed about the cards, example 19. And I think we are given explanation for all the 5 questions. Now we'll start the exercise 7.4. I think first question you can solve, second one of the question we'll discuss now. After the time also people are joining. Okay, second, determine n if 2nc3 upon nc3 equals to 12 is to 1 or 12 upon 1. So if it has to be true, what should be the value of n? So what we do here is, uh, so let me copy the question. 2nc3, this is second one question. Yeah, let me copy this one. This is 2n 2nc3 is equals to, given 2nc3 equals to nc3 c3. So then what is the value of n? So any guess, any suggestions, how can we solve it? So as usual, we'll apply the formula of NCR. So what is the formula of NCR? N factorial upon n minus 2 factorial, n minus r factorial into r factorial, right? That is the, let me check it, even 2nc3 upon, it's not equals to form. Equals to 6 squared upon 1. So let me expand the formula of the numerator. So what you get if I expand according to the formula, here you will get 2n factorial upon, you will get it as 2n minus 3 factorial into 3 factorial. Everyone agree with this formula? 2n factorial upon 2n minus 3 factorial into 3 factorial. Now denominator we have is nc3. So the formula for nc3 is n factorial upon, this is going to be n minus 3 factorial into 3 factorial, which is equals to, you get 12 upon 1. Okay, so next step, let's see what we can. Next, any cancellations we have? Can we do any cancellations here? Students, it will be strict warning. If you are joining after 9 o'clock, I am not going to allow. It's disturbing the class a lot. Please join before 9 o'clock. I am sending the link 10 minutes before. Still you are joining late. Tomorrow onwards, no class will be. You are not allowed to join after 9 or after 10 or after 11, whatever the timing is given. It is disturbing those who are on time. Okay. Now here what we can do is this 3 factorial and here also 3 factorial, both will get cancelled. Now what I do here is I'll keep this Okay, let me copy this one. So this 3 factorial I can remove from the denominator. What we do is into the denominator fraction, this n factorial upon n minus 3 factorial, I can take it as a, okay. So to do that, let me rearrange these things. It looks hard. Yeah, into, let me take the reciprocal. So if I take the reciprocal, I'll get n minus 3 factorial upon n factorial. So this n factorial upon n minus 3 factorial is going to be reciprocal. It is fraction upon fraction, so denominator fraction will be reciprocal. Now, which terms I have to expand? What do you think? 2n factorial is bigger or 2n minus 3 factorial is bigger? Which one is bigger out of these two? 2n factorial or 2n minus 3 factorial? Let me see somebody. Yeah, 2n factorial is bigger one. So as usual, according to our phenomena, we are going to expand the bigger terms. So till you reach the smaller term, it can be 2n multiplied by uh, 2n minus 1 multiplied by 2n minus 2 multiplied by 2n minus 3. I stop here. It is factorial upon your denominator will be 2n minus 3 factorial. This is what I expanded 2n factorial till I reach the 2n minus 3 factorial. Okay. So then multiply by, now next n minus 3 factorial I have to expand, or n minus of n factorial. So I have to expand n factorial to the till I reach n minus 3 factorial. So numerator n minus 3 factorial I'll keep as it is, and the denominator I'll keep it as n multiply by n minus 1 multiply by n minus 2 n multiply by n minus 3 factorial, okay, which is equals to 12 upon 1. I'll keep 2 only. I think here we missed the, okay. Now here after cancellations, 2n minus 3 factorial in the denominator, 2n minus 3 factorial in the numerator. So both the terms will get cancelled. Now what you left out at the end is, let me write the equations one more time. The terms which I left out. Here I 2n is left out, multiply by 2n minus 1 will be left out. The next term is 2n minus 2. What I do is I'll take 2 common, 2 into n minus 1. Just I have taken 2 common because this 2n minus 2, so we can take 2 common. Rest other 2n minus 3, 2n minus 3 factorials both will get cancelled. Now when it comes to this fraction here, n minus 3 factorial will get cancelled. So numerator 1 will be left, denominator n into n minus 1 into n minus 2. So here I have read that terms, n multiply by n minus 1 multiply by n minus 2, sorry, n minus 2, which is equals to 12. So finally we are going to get a quadratic equation or cubic equation which we have to solve. Here you see any things are getting cancelled, n is getting cancelled because here also n multiplied, denominator also n is multiplied, so both n will get cancelled. Here n minus 1 in the numerator, denominator also n minus 1 will get cancelled. So let me write out what are the things are left out. Left out with 4. 4 is coming because initially you have 1 2. Here also you have another second time 2. So 2 2 is a 4. Multiply by 2n minus 1. And in the denominator you have n minus 2 is equals to 12. So now I think you can simplify this one. To simplify, this 4 will get cancelled in 12 3 times. So finally I left with 2n minus 1 is equals to 3 times n minus 2. Okay. So if I want 2n minus 1 is equals to minus 6. So if I simplify, I think I am going to get n equals to 5. My value of n. Is that clear for everyone? Okay, good. What you're going to do is this first question also same way. You have to expand according to the formula as per the requirement. First, you expand this NC8 equals to NC2. You'll get the n value. For example, n is coming 6. Then you have to find 6C2 value. If n is coming 8, then 8C2 value. Like this. Even the second question also the same way. You can solve it. Now, third question, how many chords can be drawn through 21 points on a circle? That means on the circle, if I have 21 points, how many different chords you can draw? So to simplify and understand easily, what we do is first, we'll take this question into the simple. Instead of 21 points, for example, let me take 5 points. So that's easy to understand. Then 21 points you can expand it easily. So let me insert the save. Just give me 1 minute. Okay. So let me take the points on the circle. Any 5 points. 1 point. You take anywhere in the circle. This is second point. Just a minute now. I can take inserting shapes. Second point. Maybe third point. I'm locating as my wish. You can keep anywhere on the circle. It doesn't matter. So I'm taking 5 points because drawing the diagram for 21 points, it will be a little bit difficult. So let's make it 5 points, then you can understand. Now, let me try to draw all the possible chords. For example, from here to here, I'll draw. This is one chord. Now, from first point to second point, the chord which will be same as from second point to first point. Do you agree? The chord will remain same. So that means if you draw chord from one point to second point, then no need to draw the chord from second point to first point because it's already done. Now let me draw the second one. This is going for second chord. Now from the same point, I'll draw to the third point, and from the same point, I'll draw the chord to the fourth point. This is the chords I drawn from the first point. Now you can do the same thing from the second point also. Now from the second point, I no need to draw the chord to the first point because it's already there. Now from second point to third point, I'll make it. Okay. Now again from second point to fourth point. Now second point to fifth point. This is done. So let me point out from the first point, we have drawn four cards. Four cards. Yes. From the second point, I have drawn three cards. Yes. Then we have insert shapes here. From the third point, I no need to draw the first point. I no need to draw the second point because already the cards are drawn. I have to draw from third point to fourth point. Let me take the different color. Yeah. From third point to fifth point. So that means you can draw maximum two cards from third point. So press 2, press. Now finally from the fourth point to the first point, already we have this blue color card. From fourth point to second point, we have this orange color. From fourth point to third point, we already have blue color. Now fourth point to fifth point, we don't have the card. So if I join it, you may put the different color. This one, maybe yellow color. Yeah. I think we have drawn all the cards from every point to another point. So from fourth point to fifth point, I can draw only one card. So number of cards I can draw for the 5 points is 4 plus 3, 7 plus 2, 9 plus 1. Okay. So I am trying to solve this question not by combination way. We can solve this question by a logical way also. Now similarly, if I have 21 points, can anyone tell me what are the numbers to be added? Dev Godania, I have to start from 21 or I have to start from 20? It will go till 1, not till 2, because from the last point, from 20th point to 21 point, there should be a card. So it will go till 1. 29, Krishna Patel. I think it should be 20. You might be typed wrong. Yeah, it's go from 20 plus 19 plus 18 plus 17. I think this is the sum of natural numbers. First 20 natural numbers. You remember the formula? In AP, we derived the formula in class 10. Sum of n natural numbers n into n plus 1 upon 2. This was the formula which we discussed in class 10 arithmetic progression chapter. N into n plus 1 upon 2. Sum of first n natural numbers. So you have 20 plus 19 plus this are. So you can add this. I think 210 cards you can draw. If my calculations are correct, you can get 210. You have to remember that. That is the third question answer. So similarly, we have one more question also. In a party, if there are 100 people, okay, and each one shake hands the other, total number of shake hands will be how many? How many shake hands will be there in total? So the similar type of questions. First person will give the shake hand to second person, which will be same as second person is also giving the shake hands to first person. It is similar to the same question. There you have the persons, here you have the dots. Sometimes they may ask that type of question also in the exam. Be careful. Next one, in how many ways? Is the third question is clear for everyone? Yes or no? Okay, good. Okay, fourth one, in how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? I think we saw this type of questions. 5 boys are there, 4 girls are there. So this is fourth question, right? Given 5 boys and 4 girls, to make a team of 3 boys and 3 girls. So can you tell me how many ways we can do? Any guess? Out of 5 boys, I have to select 3 boys. Out of 4 girls, I have to select 3 girls. So it is a selection. That means I have to go for the combination. See, same boys girls question will come in the permutation also, but that is about arrangements, and this is about selection. So the answer is going to be, let me see if somebody has given the answer. 5C3 into 4C3. Out of 5 boys, I have to select 3 boys. So it is 5C3 multiply by. Why I'm multiplying? I want boys and girls, not only boys or girls. Okay, that's why multiplication is coming. If it is unconditioned, then it will be a multiplication. Now, out of 4 girls, we have 4 girls in total. I have to select 3 girls. So 5C3 into 4C3. Don't leave the answer here, simplify. What is 5C3 value and what is 4C3 value? Find out, multiply, and give the final answer. Okay. Easy, right? Now, I'm leaving this calculation part here. I think you can simplify how to find 5C3 and 4C3 values. Next one, find the number of ways of selecting 9 balls from 6 red balls, 5 white balls, and 5 blue balls if each selection consists of 3 balls of each color, 6 red, 5 white, 5 blue, and total you have to select 9. And what is the condition? There should be 3 balls of each color. So give me the answers. Out of 6 red balls, you have to select 3. Out of 5 white balls, you have to select 3. And out of 5 blue balls, you have to select 3. So total I'll get 9 and 3 of each color. Let me check if anybody has given the answers. No one? 6C3, 5C3, 5C3. Yes, your answer. Out of 6, I have to take 3. So 6C3. Out of 5 white, I have to take 3. So 5C3. And out of 5 blue balls, I have to select 3. So it will be 5C3. Okay. So I think these are the next. Determine the number of 5 card combinations out of a deck of 52 cards if there is exactly one ace in each combination. So here the question is one ace should be there out of 5 cards. So how can I do that? Any ideas? Sixth question, I think. Out of 52 cards, you have to take 5 cards you have to pick up, and one card is ace. Out of 5, one should be ace. So any guess? How many ace cards we have? Let me see if somebody has given 4 ace cards. So out of 4, I have to select one. So it is going to be 4C1. Out of 4, I have to select one. Then only I'll get one ace card compulsory. Otherwise, if I out of 52, if I take, there might be some cases where I don't get the ace card at all. So what I do is first, out of 52 cards, I separate 4 ace cards as one and remaining 48 cards at one place. So out of 4, I'll take one. Okay. 4C1. Out of 4 ace cards, I can take one. They said there should be at least one. That means you can have more than one ace cards. So after of taking out of 52, one ace card I have selected. Now how many more are left? 51 cards more are left. So out of 51, I have to select 4 more cards. Why I'm selecting 4 more? Total I want 5 cards. One ace card is selected. So I need 4 more cards out of 51. But here the question they clearly said exactly one ace card. Sorry. If it is exactly one ace card, it cannot be 51. It has to be 48. I cannot select other ace cards. Is that explanation clear? Let me go through it once. So total 52 cards we have. I divided into two groups. One group has 4 ace cards separately, remaining 48 cards separately. Out of 4 cards, I select one. So that can be written as 4C1 into remaining out of 48 cards. I have to select 4 more cards because total I need 5 cards, right? One is ace, 4 more cards I have to select. So it will be 48C4. Now here initially I written 51C4. There is a reason I written because I not read this condition exactly. I did not remember. So if they want exactly one ace card, that means after selecting one ace card, remaining 4 cards which you are going to select, in those 4 cards there should not be any ace card. Okay, so that means other 3 ace cards I have to keep it side. After selecting one ace card, other I have to keep it side. Remaining 54 48 cards, I have to select remaining 4 cards. So this is 4C1 into 48C4. If they don't use the word exactly, if they say 52 card, if there is at least one ace card, instead of exactly, if they use the word at least one ace card, then 4C1 into 51C4. Because out of other 4 cards, I might have ace cards also. But here they said exactly only one. So that means after selecting one, the remaining 3 ace cards, I have to keep it side from a deck. So that is going to be 48C4 because remaining cards will be 48. Out of 48, I have to select 4. Is this clear for everyone? Yes or no? Okay, good. Next one, what we have, fifth, sixth also discussed. Seventh one, in a in how many ways can one select a cricket team of 11 from 17 players in which only 5 players can bowl if each cricket team of 11 must include exactly 4 bowlers? Total you have 17 players, out of 17 5 can bowl. So first write down what is the data is given. You have 17 players, out of 17 have 5 bowlers. Now you want a team of 11 players. Out of 11 players, there must be exactly 4 bowlers. 4 only? Yeah, exactly 4 bowlers. Yeah, what can you do now? How do you solve this one? I am waiting for your answers. Take your time. Give the answer. You can take 1 minute time, no problem. Let me check if anybody has given the answers. Somebody has given 12C5 into 11C4. 17C5. Gauri. It's wrong. Yeah. See, if I take 17C5 into 11C4, that means you are selecting total 11 players only. Acha, you are given, I understood what your answer given. 17C5 you are given into 11C4. This is how you given the answer. No. This is the total availability of the persons with me, and this one is my requirement. The question is out of 17 players, I have to select 11 players, and out of 17 players, you have 5 bowlers and you need 4 bowlers. If I want 4 bowlers compulsory, so I have to select out of these 5 only. Do you agree? So if I select out of these 5 bowlers, I want 4. So this can be done in I see 4 ways. Because total I have 5 bowlers. I need to select 4 bowlers. That's done. Now multiply by. Now out of 11 players, I already selected 4. But the denominator 5C4, 4 represent the selected person. Out of 11 players, 4 already selected. How many more I want? 7 more I want. 7 more if I keep here, 7 more I want. It has to be done selection. And here, how many more are left? Out of 17, 5 bowlers if I remove, how many more are left? 12 more are left. Out of 12, I have to select 7. Now, if you see, if you add 5 plus 7, 5 plus 12, which is going to be 17 players, and 4 plus 7, which is going to be 11 players. So, out of 17 players, I already selected 11 players. And what basis? Out of 5 bowlers, I need 4 bowlers. So, that is also selected 5C 4. See, this black color one is not the given data. This is the required data. How do I select this way? This red one is the given data. These are my total resources which I have. Out of these resources, I have to make this team. How do I make it? How many ways I can make it? Is that clear, Gauri? Okay. So that is done. Next, eighth question. A bag contains 5 black and 6 red balls. Determine the number of ways in which 2 black and 3 red balls can be selected. So I think you can give me the answer quickly. Out of 5, I have to select 2 black. Out of 6 red balls, you have to select 3 red balls. So how many ways we can do that? So given 5 balls. Yeah, now I think Gauri has given the correct answer. Yes, it is 5C2 into 6C3. Perfect. Next, what we have? Last question. In how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student? Yeah. How can you solve this one? There are 9 courses are available. Out of 9, they have to select 5. And out of 5 courses which is going to select, 2 courses are compulsory for every student. So how can they do this? Let me see if somebody has given the answer. 7C3. That's it. It's partially correct. How 5C2? Total courses you have to select is 5. 5 cannot be your given data. 5 is the number of courses I have to select. Okay. Here you are getting confused, I think. Number 9. Number, you have 9 courses with you. Out of 9, 2 are compulsory. When the courses are compulsory, those courses, 2 courses you can select in 2 ways or 1 way. 2 courses can be selected in 2 ways. Select the first course, then select the second course. Multiply by remaining how many courses you left out? 7 more courses are left out because out of 9, 2 already selected. 7 more are left. If 7 more are left, these are the left courses. How many more courses he or she has the option? Out of 5, 2 already selected. So 3 more are left. 2 into 7C, 3. Can I put here 2? 2 courses can be selected in 2 ways or it can be only 1 way. I think this can be only 1 way. Sorry, it's not 2 ways. This can be only 1 way. I think 7C3, only your answer is correct. Because those are compulsory courses. They have to opt it. There is no option. So both the courses they can pick up. First course can be done in 1 way. Second course also can be done in 1 way. 1 into 1 is 1 only. So 1 into 7C3 is 7C3. Okay. Oh. There are different answers. Muhammad 9C2. See, if I say 9C2, do you know what do you mean by 9C2? Out of 9 courses, I have to select 2 courses. So I can select any 2 courses. How can it be compulsory courses, right? Compulsory courses are the courses you have to take anyhow. So that can be, for example, I have to take maths compulsory or maths compulsory. So just up the math subject that can be done in only 1 way. There is no other way to do that. If I want biology compulsory, so select the biology course. That's done. But remaining 3 subjects out of 5, 2 already selected. Remaining 3 subjects, how many ways I can do? Out of 7 are left out. Out of 7, I have to select 3. So it will be 7C3. Now, Gauri, again, you are given a wrong answer. 9C5, 7C3. You know, total 5 plus 3, 8 courses you are selecting. But I want only 5. If I write 9C5, which means out of 9, I can take any 5 courses. But that is not the question, okay? Please understand the question before you attempt it. Take 1 or 2 minutes, no problem. and do it correctly. I think we have done the exercise question. So now we have some miscellaneous examples. Yeah, 21 I'll explain. A group consists of 4 girls and 7 boys. Let me write here. Example, the data is given 4 girls and 7 boys. 2 girls and 7 boys. Okay. In how many ways can a team of 5 members can be selected? First question, no girl. Second question, at least one boy and one girl. At least 3 girls. So first I'll go for no girl. A team of 5 members. Okay. You have to make a team of 5 members. Okay. So how you are going to team of 5 members? You have to select 4 girls are there, 7 boys are there, and the first question given to us, no girl in the team. So how many ways you can do? If no girl means I have to select all boys only. Let me see if somebody has given the answer. 7C5, 7C5, 7C5. What about other students? Okay, no girl means I have to select all the boys. How many boys I have with me? 7 boys. So out of 7, I have to select 5. So it is going to be 7C5. That's the final answer. Okay, you can put it as 7C. Because from the girls, I cannot take anyone. Is the condition they are given to us. No girl. Now, what about the second question of this one? At least one boy and one girl. So, how do you go work on it? One boy and one girl. So, I'll go for the cases here. My first case, let me start this one. Only first, one boy and one girl. Minimum, I want one boy and one girl. It can be more than one boy and more than one girl, but total should be 5 members only. If I take one girl, it will be 4C1 into others will be boys. So out of 7, I have to select 4. This is the first case. One girl, 4 boys. What about the second case? Or case 1 means it can happen first case, or it can happen second case, or it can happen third case. So wherever I use the or, so I am using plus sign. Here I use the word and, that's why I am multiplying. One girl and 4 boys. So this will be one case. One girl and 4 boys. And I use, so I multiply. So this will be the case 1. Or it, if I stop here itself my answer, then what it gives me is one girl and 4 boys. But the question is at least one girl. That means 2 girls also can be possible. 3 girls also can be possible. 4 girls also can be possible. 5 girls is possible? No, because I have maximum 4 girls. So here I have to go for different criteria. So let me copy the entire thing. Second case is, this first case I given is one girl and 4 boys. Another one I'll give you as 2 girls. If 2 girls are there, then it will be 3 boys. Then I'll go for another case. One girl, 2 girl. Then I'll go here for 3 girls. If there are 3 girls, then there will be 2 boys. Plus total I have to maintain still 5 only. Plus, then I'll go for 4 girls and 1 boy. If there are 4 girls, I can have only 1 girl. That's it. Is there any other possibility? This is case 1, which explains me 1 girl and 4 boys. This is case 2, where number of girls is increased and boys are decreased. 2 girls and 3 boys. And here 3 girls and 2 boys. And here 4 girls and 1 one boy. Now next 4C5. I cannot take 4C5. Out of four girls, how can I select five girls? It's not possible. Now you may have doubts of why we have to start with the girl only. We can start with the boy also. So if I go by this way, this will explain me from the boys. Like you can see here, first one boy, four girls. This is the case one. This is case two, two boys, three girls. Here boys are increasing and girls are decreasing. Three boys, two girls, four boys, one girl. You may sir, why I can take now five boys because I have seven boys, so I can take five boys and zero girls. If I take five boys and zero girls, which means no girl, but the question asked here it is at least one girl and one boy compulsory. So I cannot take zero girls. So that's why I'm not going for 7C5, 4C0. Is this clear for everyone? How to solve? Yeah, I think 4C1, 4C3, yes. So this is how you have to take where you have the multiple option. Third one is at least three girls. Now give me the answer for the third question. At least three girls, minimum three girls. At least means minimum three girls, so you can have more than three also. So I'll wait for your answer. Send the answer and see what you are given. Answers. Typing is taking time. Yes, it's a part of the question. This will be the answer of third question. At least three girls means you can have three girls and two boys, or four girls, one boy. Okay. So part of this one is going to be the answer for third question. See, while I am explaining, I am not writing any statement, but you can see the answer, the way they are given the answer here. So all these things you have to write it carefully in the exam. Okay. Just we are discussing, so that's why I not mentioned all. And you have to simplify all these factorial also. 4C1 is 4 into 7C4 values you find out. They are given all the answers here. See, 84 plus 7 is 91, which are easy to simplify. At least those things we should simplify. Okay. So that is all about your permutation and combination chapter. You try miscellaneous examples also. If any doubt, next class you let me know. We'll discuss. Okay. Any other doubts from this class?